Lesson 1-10 is compute with scientific notation. Now, because numbers in scientific notation contain exponents, sometimes the law of exponents can be used when simplifying. So, just as a reminder, if we are multiplying powers, what do you do to the exponents? You add them. If you are dividing powers, you subtract. And when you have a power raised to a power, you multiply. All right. So for example 1, we're multiplying with scientific notation. Now when multiplying, we can use the product of property powers. And again, when you are multiplying powers, you add the exponents. So example 1a says a dime is 1.35 times 10 to the negative 3 meter thick. What would the height be in meters of a stack of 1 million dimes? So for this one, the important information here is that we have a dime that is 1.35 times 10 to the negative 3 meter thick. Okay? And we want to know if we stack dime and dime and dime and dime, we want to know if we stack 1 million dimes together, we want to know how tall it's going to be. So we're going to multiply 1.35 times 10 to the negative 3 times 1 million dimes. Now, if we're stacking 1 million dimes, let me just write 1 million out here. What is that written in scientific notation? Well, that's going to be, if we're moving the decimal, it's going to be 1 times 10 to the 6th power. Now, when we're multiplying, remember, we have the associative property. So we can multiply in any order we want. Okay? So in this case, we're going to multiply our constants. And then we're going to multiply our powers. Okay? So 1.35 times 1, of course, is itself. That's 1.35. Times, now we've got 10 to the negative 3 times 10 to the 6th. So negative 3 plus 6 is positive 3. So this is going to be times 10 to the 3rd meters. And now, just to put it in terms that you're familiar with, if I wanted to change this to standard form, we would just move the decimal 1, 2, 3 units to the right, annex a 0 there, and in standard form, that would be 1,350 meters. So a stack of 1 million dimes would be 1,350 meters tall. So I want you to press pause, and then I want you to try example 1b on your own, and then press play again so you can see the rest of the solution. All right, so for this one, we have, it says the speed of light is about 1.9 times 10 to the 5th miles per second. It takes about 500 seconds for the light to travel from the sun to the earth. We want to know what is the approximate distance between the earth and the sun. Now this one is a little different than the previous example. As a matter of fact, I think I'm going to take this solution out and I'm going to go step by step. So this is the speed of light. The speed of light is 1.9 times 10 to the 5th power miles per second. Now this is what's different about example B and example A, is this one has a miles per second, which means that this is going to be a fraction. Okay? Now, it says it takes about 500 seconds for the light to travel from the sun to the earth. Now, 500 seconds if I want to write that with scientific notation, that is going to be 5 times 10 to the second power. Okay? And now we want to know what is the approximate distance between the Earth and the Sun. So on this one, we're going to multiply 1.9 times 10 to the 5th. And here I'm going to write miles per second. Okay? And then we're going to multiply this times 500 seconds, and we're going to write this one as 5 times 10 to the second power seconds. Okay, and we're going to put this over 1, just so you can see it's fraction and fraction. Okay, now we need to start simplifying a little bit. Okay, so we're going to simplify the seconds. As you can see, there's seconds in the denominator, there's seconds in the numerator. So those can cancel. Those cancel out. Oops. So now you can see that the only unit we have left is miles. And that helps because we want to know what is the approximate distance. So miles is what we're looking for. So now we can multiply straight across. So let's do that. We're going to multiply our constants, and we're going to multiply our powers. And again, our unit is going to be miles. That's what we're going to end up with. All right, so we're going to multiply 1.9 times 5, and that's going to give me 9.5. 9.5. And then we're going to multiply times, and here we got the powers. 10 to the 5th times 10 to the 2nd. That's 10 to the 5 plus 2. So that's going to be 10 to the 7th power. So this is going to be 9.5 times 10 to the 7th miles. And now, just to, again, write the number in something that you are familiar with, we're going to take this decimal and we're going to move the decimal 7 units to the right. So that's 1, 2, 3, 4, 5, 6, 7. And at each one of those, we are going to annex a 0. So, in standard form, the distance between the Sun and the Earth is 95 million miles. All right, so for example 2, we want to divide with scientific notation. And again, when we are dividing powers, we subtract our exponents. All right, example 2a says, in a recent year, the population of China was about 1.3 times 10 to the 9th power. According to the census data, the population of the United States was about 308,745,538. And we want to know about how many times greater was the population of China than the population of the United States. So, when we're doing a comparison, we want to know how much greater. This is how many times greater. That means we're going to divide. So since we're comparing China to the United States, I'm going to label it here, China, and then the U.S. Okay? So China was 1.3 times 10 to the 9th power. And then the U.S., you look up there, it's not in scientific notation, so we want to write it in scientific notation. So when I write it in scientific notation, if you'll notice, down here, we have 2 significant figures. So that means that we want to have 2 significant figures in our other number. So right here, there's our 2 significant figures. Now when we round, that 8 tells us we want to round up. So that's going to be 3.1. Okay, so the factor is going to be a 3.1. And now we need to see how many times we move that decimal to get it there. So that was, let's see here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is going to be times 10 to the 8th power. And now, again, we divide. So here we are dividing our constants, and then we are going to divide our powers. Okay? So when we divide 1.3 divided by 3.1, that's going to give us, I'm going to write 0.419. Okay? So this is going to be equals 0.419 times 10 to the 9 minus 8, which is 1. So in this case, we've got 0.419 times 10 to the first. Well, guess what? 10 to the first is just 10, right? So if I multiply, and you don't even need a calculator for this, but if you're multiplying 0.419 times 10, that's going to give you 4.19. So this says that China's population is about 4, or 4.2 if we want to round to the nearest 10, 4.2 times greater than the population of the United States. Let's write that down. All right, so now I would like for you to press pause and try to do example 2B on your own, and then play again for the rest of the example. And on this one, I'm going to show you this trick right here. All right, so it says the largest planet in our solar system is Jupiter, with a diameter of, let's say of, about 143,000 kilometers. The smallest planet is Mercury, with a diameter of about 5 times 10 to the third kilometers. About how many times greater is the diameter of Jupiter than the diameter of Mercury? And we want to write our answer in scientific notation using the correct number of significant digits. So this one, it says we are looking for, we want to know how many times greater is the diameter of Jupiter than Mercury. So we're comparing Jupiter to Mercury. Okay, so Jupiter is right here, 143,000. We need to write that in scientific notation. So this is going to be 1.43 times 10 to the, let's see, 3, 4, 5, to the 5th. Okay? So we're going to write that for Jupiter. So that's 1.43 times 10 to the 5th. And we're dividing that by the diameter of Mercury, which here is 5 times 10 to the 3rd. So 5 times 10 to the 3rd. Now, it says here, write your answer in scientific notation using the correct number of significant digits. Now, when you look at these two numbers, we've got 3 significant digits here, and we have 1 significant digit there. So when we are trying to decide how many significant digits our answer has to be, it has to be to the least of the accurate numbers. So that means that our answer has to have 1 significant digit. So here we are going to divide our constants, and we are going to divide our powers. So we've got 1.43 divided by 5. That's going to give us 0.286. So that is equal to 0.286. 286 times 10 to the 5 minus 3, that's 10 squared. And of course, this is going to be kilometers. Okay? Now, actually, we don't need to write that. That's just going to be how many times. So now we've got this. Now, if you look at this, this is not in scientific notation because our first factor, first factor there is not greater than or equal to 1 and less than 10. So we need to make it that. So we need to move the decimal so that it is, so that we have a number that is greater than or equal to 1 and less than 10. So when we do that, we're going to move the decimal to the right between the 2 and the 8. Now, because, and here's the trick here, when we move the decimal to the right, that means that we need to subtract that many movements from our exponent. So we're going to subtract 1 from our exponent. So this is going to give us 2.86 times 10 to the first. Okay? So, again, we only want one significant digit. So that means this is the one significant digit. We have to round using the 8. So this is going to give us 3. So our final answer is going to be 3 times 10 to the first power. Okay? So Jupiter's diameter is 3 times 10 to the first times larger than Mercury's. Let's write that down. So example 3, we want to add or subtract with scientific notation. Now I want you to please make sure you write down these steps. Okay? We have step 1, which is write the expression with the same exponent. Step 2 is to use the distributive property to factor out the power of 10. Step 3 is to add or subtract the constant factors, and then step 4 is to rewrite in scientific notation. And that's when we'll be using our little trick if we need to. All right, so for example A, it says 8.41 times 10 to the third plus 9.71 times 10 to the fourth. Now, we want to rewrite so that we have the same exponent in the powers, okay? So, that means, let's see here, I think we can change them to both 3's. So if I'm going to move that decimal to the right, one place. So that means I need to subtract, if I'm moving to the right, I need to subtract, right there, from the exponent. So we are going to subtract 1 from here, subtract 1. So now I'm going to rewrite. So I have 8.41 times 10 to the third plus 97.1 times 10 to the third. Okay? And now, step 2 says that we want to use the distributive property to factor out the power of 10. So remember when we factor out, remember we factored out the GCF? Here we're going to factor out this power of 10. That's going to go on the outside of the parentheses. So that's going to be 10 to the third on the outside of the parentheses, and I'm going to put it at the end because that's where it is in scientific notation. And then we're going to add 8.41 plus 97.1. So when I rewrite this, it's going to be on the outside, This is going to be like times 10 to the third power. Okay? So now we just add those. So when we add those, this over here, we've got 8.41 plus 97.1, and that gives us 105.51. So this is 105.51 times 10 to the third power. Now, again, you'll notice this is not in scientific notation. So I need to move that decimal to the left 2 places right here. And because I moved left 2 places, I need to add to the exponent. So we're going to add 2 to the exponent. So here this is going to give us 1.0551 times 10 to the 5th power. Now, if I want to write this to the correct number of significant digits, you'll see up in the problem, there's 3 here and there's 3 here, so I need to have 3 significant digits in my answer. So we're going to round to the hundredths place. So that 5 tells us we want to round up. So this is going to be approximately equal to 1.06 times 10 to the 5th power. All right, so I would like for you to pause and try example B on your own. All right, so for this one, let's change these powers to both the power of 4. So that means I want to subtract, because I'm going to move the decimal to the right one. Okay, that means I'm going to subtract 1 from the exponent. So let's rewrite. We have 6.98 times 10 to the 4th plus 92.4 times 10 to the 4th. Okay, so now we're going to factor out that power. Okay, and we're going to put it at the end. So we've got times, we've got times 10 to the 4th power factored out, and then what's left is 6.98 plus 92.4. So when we put that together, so when we add here, this is 6.98 plus 92.4, and that gives us 99.38. So this is 99.38 times 10 to the 4th. Now we're going to use our moving the decimal trick. We need to move this to the left. So when I move to the left 1, moving to the left, I need to add to the exponent. So we want to add 1 to the exponent. So this is going to give us 9.938 times 10 to the 5th power. And now I want to check my significant digits. Okay, so you can see here that we have 3 here and 3 there. So that means we need 3-digit significant figures in our answer. So we're going to round to the nearest hundredth again. So that 8 tells us we want to round up. So my final answer here is 9.94 times 10 to the 5th power. All right, so example 4 is an application. It says the mass of a grain of sand is approximately 4 times 10 to the negative 6 grams. The mass of a grain of rice is 0.00002985 kilograms. We want to know how many times as great is the mass of the grain of rice than the grain of sand. So on this one, we are comparing the rice to the sand, okay? So we got to make sure we set up our fraction correctly. So we're going to do rice to sand, okay? So the let's see, the rice is this one. We want to write that in scientific notation. So the decimal needs to go, let's see, 1, 2, 3, 4, 5 units to the right. So this is going to be 2.985 times 10 to, and this is a very small number, so this is going to be a negative exponent, right? That's going to be 1, 2, 3, 4, 5, negative 5. Okay, and we're going to divide this by the grain of sand. So the sand is this one. So this is going to be 4 times 10 to the negative 6. Okay? And now we're going to divide our constants and we're going to divide our powers. Okay? Now remember, when we're dividing powers, we subtract our exponents. When we are dividing numbers, we just divide the numbers, right? So here, this is going to be 2.985 divided by 4, and that gives us 0.74625. Let's see here. See if I can remember that number. Oh, I can't. 0.74 0.74625 times 10 to the, now I'm going to write this up here. This is negative 5 minus a negative 6. Now remember, you're going to do keep, change, change. So that's going to be a positive 1. Okay, that's a positive 1. So now we want to change back to scientific notation, because you can see this, of course, makes it not scientific notation. So we need to move that decimal to the right 1 unit. So if we're moving to the right, where are we going? Moving to the right, we need to subtract from the exponent, right? So we're going to subtract 1, since we only moved once, we're going to subtract 1 there. So this gives me 7.4625 times 10 to the 0. Well, what's 10 to the 0? That's equal to 1, right? So this right here, that's equal to 1. So this gives me 7.4625 times 1. Of course, you could do this part in your head. You didn't have to write that down. Just do it. And then this would be equal to 7.4625. So if I said, let's see, does it tell us to round to anything? Nope. Nope. But I'm going to say round to the nearest 10th. We'll say to the nearest 10th. So we can say that, here's rounding, there's the 10th place. So the 6 tells us that we want to round up. So this is going to be 7.5 times greater. That says that the rice is 7.5 times greater in mass than the grain of sand.